Hi there and welcome to another video 7, and this is a tutorial on circles. As always with these videos, these are help to students who have previously done the foundation paper and trying the higher paper, and their explanations of the topics that are coming up in the higher AQA Unit 3 that a previous foundation student should be able to do. Okay, this topic is circles. It's going to build on our knowledge from foundation topics of circles, and we're going to show how we can answer the higher questions there. After you've done this video, I expect that you would have a revision card that summarizes this video, and then you move on to the accompanying video 8 past paper exam questions on circles. Okay, let's start straight away. Okay, here we have a circle, and this is the center of the circle, and so we need to be able to label some key things about the circle. Now, a line from the center to the perimeter of a circle or the outside of a circle is called a radius. Okay, that's a radius there, and the distance around the outside of a circle has a special name, and that's called circumference. The circumference is the perimeter of a circle. Circles have their own name for their perimeter. Now, a line joining from the one edge of the circumference to the other, going through the center, okay, this needs to go through the center, is called a diameter. So this here is called a diameter, okay, going through the center. And it's clear that the diameter is 2 lots of the radius, so the diameter is always 2 times the radius. Now, how would you remember these terms? Well, radius is like a sun ray. It's a line coming out from the center of the sun, like a ray. So radius, you might remember it that way. Diameter is just double the radius, d for double, and the circumference is the distance around the outside, so that starts the same as a circle. There are a couple of other things we should really know about a circle, and we should know the following. The area enclosed by 2 radii of a circle, so this sort of this area here in there, is what's known as a sector. That's a sector. It's almost like a slice of a piece of circular pie. A sector is this area enclosed in here, and this is where the higher circle work focuses on. It really focuses on sectors, and a part length of a circumference, say a little part of the circumference, like this amount here in this sector, that amount of curved distance there, that's not the whole circumference, that's part of the circumference, and we call it an arc, okay, or an arc length. Okay, so they're the main things. There's a couple of other things that you might know, but they're the ones that come up most often, so just focus your attention on learning those. Now, you should know from foundation work the area of a whole circle. The area of a whole circle is pi r squared. Okay, and you must be able to remember that. That's not given in the formula booklet. I remember it because I think areas usually units are centimeters squared or meters squared. Hence, I know pi is going to be in there, r squared. The squared matches with the unit. That's how I tend to remember it. Okay, and the other thing you need to know is the distance around the outside of a circle, how to work it out. Okay, the distance around the outside, how to work out the circumference. Well, that is 2 pi r. And the way I remember it, if I remember the area one, I just bring down the 2 in front, and I've got 2 pi r as the circumference. So if I can remember the area one, I almost get the circumference one for free. Okay, what do these things mean? Well, pi r squared means pi times r, and 2 pi r means 2 times pi times r. Okay, that's how we use those formulas there. Just want to show you on a picture of a calculator where the pi button is, because in higher, you don't want to be using pi as 3.14 as you might have done in foundation. You want to use the pi button on your calculator. So on this picture of a calculator here, I know a lot of people have got it. The pi button is actually here, and you have to press shift that button to get pi, and you'll get pi. You need to find on your calculator where the pi button is. Okay, so key things here, you need to know what a sector is, an arc length. They're the two new bits of information probably for you, and you should know radius, diameter and circumference, and you should know the two key formulas, that the area of a circle is pi r squared and the circumference is 2 pi r. Okay, I'm going to do a couple of questions now, and I want to show you, most of this is foundation, so how to work out areas and circumferences of circles, and then we're going to move on to some genuine higher paper circle work. But this foundation work does come up as well. So let's take a look at some questions. Here we go. There are 4 questions there, and I want to show you how to set your working out properly and to get the answer right every time. Okay, here's a circle. It says find the area. The first thing I would do, I always write down what I know about the circle. I know that the radius is 3, okay, centimeters. I always want to write down the radius, okay, at some point before I start the question. I also know the area formula of a circle. The area, okay, well, area is measured like centimeters squared, meters squared. So I'm going to remember, this isn't in the formula booklet, that the area of a circle is pi r squared. Okay, pi r squared. So to work out the area of this circle, I do pi times 3 times 3. And I would get, if I would say round to 1 decimal place, 28.3 centimeters squared. Okay, and I'm done. Quite easy. Now, want to make a really big point about this. In the higher paper, they tend to say leave your answer for the area in terms of pi. Okay, so they don't want it worked out to decimal places. They want it in terms of pi. Well, in most calculators, if you type pi times 3 times 3, they will leave it in terms of pi, and it would be 9 pi. Okay, and if your calculator doesn't do that for you, the unit again is centimeters squared. If your calculator doesn't do that for you, just leave the pi alone, forget about the pi, and multiply all the numbers left together, and then whatever you get, so 3 times 3 here is the 9, and write your pi after it. So this is a higher paper sort of question. Instead of using, in the foundation you would have that question, and it would say using pi is 3.14. Now, either if we're doing it to decimal places, we find the pi button on our calculator, or we give it algebraically in terms of pi. Okay, this next one, find the circumference of this circle. Well, what do they tell us? They tell us the diameter is 8. So I want you to always write down your radius is therefore 4 centimeters. Okay, you need to remember the formula for the circumference. Well, the circumference is like the area formula, but you bring down the 2, is 2 pi r, which means 2 times pi times r, which we said is 4. Okay, if you work that out on your calculator, you get, say, to 1 decimal place, 25.1, and the unit here, circumference is distance, so it's centimeters. If you were to leave your answer in terms of pi, 2 times pi times 4, just times the numbers and forget about the pi, and write the pi after, that would be 8 pi centimeters. Again, this is a higher level and a higher paper type question. Okay, next question. Find the area of this here, which is a semicircle. What do they tell you? Well, they tell you the diameter is 10, so always write down your radius. Your radius is therefore 5 centimeters. The area of a whole circle, let's work out the area of a whole circle with these features. Well, that's pi r squared. Pi r squared, which is pi times 5 times 5, which we would get as 78.5 centimeters squared. So the area of a semicircle is a half that, so you would do a half times 78.5 centimeters squared, and you would get 29.3. So 39.3 centimeters squared. If you left it in terms of pi, here you would have had a half times, and this would have been pi r squared, so it would have been pi times 5 times 5, and you would have got 12.5 pi centimeters squared. Okay? Okay, find the perimeter here. Well, they tell you the radius is 6. Now be very careful here. This is one little extra technicality here. If you were to work out that distance there, that would be half the circumference of a circle. But if they want the perimeter of this shape, they also want you to add in this straight line distance here. So do not forget about that. So the half a circumference, so half a circumference would be equal to, well, it would be half times 2 pi r. 2 times pi times r, which is 6. Okay, and if you work that out in your calculator, leaving it in terms of pi for now, I would just get 12 pi. Okay, and don't forget to add in this green distance here, so we would have to add on to that 6 and 6, which is 12. So the total perimeter would be 12 pi plus 12. Okay, and if we actually work that out to 1 dp, it would be 49.7 centimeters. Okay, so hopefully you found that quite useful, just refreshing some of the knowledge you had from foundation. Next thing, we need to move on to genuine higher level topics involving circles. Let's take a look. Now, if it is a genuine higher paper question like a B or an A grade question, they tend to be about sectors of circles, i.e. parts of a circle. So here is an overall circle, and let's say the radius here was 10 centimeters. Okay, they might ask you, could you work out the area of this sector here? They might say to you, what is the area of this part of the circle here? Okay, that's a higher grade question. They also might ask you, what is the length of that distance there? So they're two higher level topics, but it's actually very, very straightforward because you just use your knowledge of normal circles. So let's take a look. Let's go for the area one first, the area. Okay, now how would you work out the area of that? Well, how much of the whole circle do I have? I know angles round a point add to 360 degrees. So how much of the circle is contained here? Well, I've got 60 degrees out of 360, okay, and I multiply that by pi r squared because that's the area of a whole circle, okay. So I would work out 60 over 360, that's how much of the circle I've got, multiplied by pi times 10 times 10. Okay, and it's as simple as that. If I was writing that to one decimal place, I would get myself an area there of 52.4 centimeters squared. Okay, and it's as simple as that. In general, if that wasn't 60, if it was some angle theta, theta degrees, the area, the general formula of the area, I'm just going to rub this out now to make a general formula of the area. The general formula of the area is how much angle you've got, theta, over 360 multiplied by pi r squared. And that is your formula for the area of a sector. Okay, what about an arc length? This green thing here is the arc length. How would we work out that curve distance? Well, it's very similar. How much of the circle do you have? Well, in this case, you've got 60 out of 360. And you've got that fraction of the circumference. And the circumference is 2 pi r. So you would do 60 over 360 times 2 times pi times 10. And you would work that out on your calculator. And rounding to say 1 dp here, I would get 10.5 centimeters because it's a distance there. Okay, so in general, I'm going to rub that out now. In general, what's the formula for the arc length? Well, it's very like the area. It's the fraction of the circle we have, theta over 360, okay, multiplied by 2 pi r, which would have been a whole circle. It's as simple as that, okay? And that is your arc length. Now, one last point to just say here. Just say they asked you for the perimeter of that shape. Having found the arc length, you'd have to add in the 10 and the 10 again, 2 radii. Okay, so just be careful if they're asking the perimeter of that shape or just the arc length, which is the curved section. Okay, we're going to do some questions now. Using this knowledge here, and these are all higher grade topics. So work through these with me, make a revision card, and you should be ready to do the exam questions then. So let's take a look. Okay, find the area of this sector. Well, we're working out area here. Let's write down what we know. The radius is equal to 5 centimeters. Okay, so how much of the circle do we have? Let's work at area. Well, we've got 60 out of 360 degrees of a circle, and we're going to times that by pi times 5 times r squared times 5. Okay, now you could write that to decimal places, but if I just do 60 out of 360 times pi, I would get the answer there I would get is 13.1 centimeters squared. If you left it in terms of pi, well, 60 over 360 simplifies to a sixth as a fraction. A sixth times 5 is 25 over 6 pi. Okay, so that is the equivalent answer, centimeters squared. Okay, find the area of this sector. Well, the area of this sector, be very careful not to fall for a simple trick here. This is this here. A sector has to be bound with inside a circle. So 60 degrees isn't the angle we're interested in. We're interested in this angle here, which must be 300. So how much of the circle do we have? Well, we have 300 out of 360 times pi times r squared, which is 5 times 5. And we can work that out the normal way. And we get 65.4 centimeters squared. Or leaving it in terms of pi, if you left it in terms of pi, you would get 125 over 6 pi centimeters squared. Okay, now it says find the arc length here. Well, the arc length is they're just interested in the curved bit today in that section. So they're just interested in the curved bit. How much of the circle do we have? Well, we have 60 out of 360 times pi times 5 times 5. Slight mistake here, sorry. 60 out of 360 times 2 times pi times r, which is 5. Okay, so if you go ahead and work that out, you would get yourself 5.2 centimeters. Or leaving it in terms of pi, you would get 5/3 pi centimeters. Okay, and find the perimeter. Well, the perimeter is almost the exact same shape, so we need that curved distance, but also don't forget to add in the radius here once and the radius again twice. So it would just be the answer above, which is 5.2 plus 10, which would give me 15.2 centimeters. Or we would get 5/3 pi plus 10 centimeters. Unlikely they would ask it in this form here. More likely they would ask it in that type of form there. So that's all you really need to know about areas and perimeters of circles in the higher levels. So we had to know all the stuff we knew for foundation, plus how to work out the area and perimeter of, say, arcs or sectors in circles. So I hope you found the following useful. Move on straight away to the next video, which will be video 8 on all the exam questions that have come up on circles in AQA Unit 3 higher. Thank you for watching.